case you forgot from last class, my name is Adam Diez. I'm going to do the gas turbine jet engine group leader report. So the objective is to analyze a jet engine that's used to create electricity. It makes the electricity in peak times whenever there's not enough in just regular operation. So when demand goes over what the hydrostatic pumps can do, they go with the jet engines. Then we're going to determine the performance numbers for the system and narrow in on ideal operating parameters. So, unfortunately, ours does not come with a little man. We have to operate it. But this is just the overview. Back here it gets real hot, so don't stand there. Well, he's standing on that side.
I know, he's an idiot. But
Oh, I guess we don't want that little man. All right, this is the control panel. Right here is the main one that matters. That's the throttle. Goes up and down. This is the master key, the start button, emergency stop. Like I said, throttle. This is the load operator. Puts an extra load from the generator. Everything else is gauges. It's all listed here. Let's see, any of them important. The 6 is the system status. It tells you if everything's going okay. If it's not, it will automatically shut itself off, I believe. So this is the overview of the jet engine itself. Air comes in through here into the compressor, goes up here into the combustion chamber, out through this turbine where it's thrust. Generally, it will be cut off right here in a jet engine. But this actually diverts it up here into a free spinning turbine that's connected to the alternator that creates energy. Again, this is the same diagram but with the sensors labeled. So inlet pressure and temperatures here. Engine RPM is measured here. Right here is the exit of the compressor, the pressure and temperature. This is the inlet of the turbine because it's coming out of the gas, out of the combustion chamber. And it's also the inlet pressure right here, right inside of the combustion chamber. Then we go to the fuel flow right here. Right here measures the inlet of the alternator turbine. So that's pressure and temperature. And then this is the exit of the alternator turbine. Oh, and then voltage generation and generator RPM are on back. So this is on the MyDAC screen. Kind of hard to read at the bottom. It's all the different things that we use. So right here is the monitor data. That's where you turn that on. It starts monitoring everything that the turbine's putting out. 2, you have 2 different options to click. This is a stop sign if it stops monitoring, or you can just hit stop monitoring right here. 3 is where you log the data to a file that's just saving it. 4 is the real-time data plots, so you can see what's actually happening. 5 here is it saves a screenshot of your data. Let's see if any of these are actually real important. I don't see any other importance. All right, so a little background. It works on the Brayton cycle. So you have intake over here, comes into the compressor, gets pressurized, goes into the combustion chamber where it ignites, leaves out of there, goes in here and puts out work. It also goes through there and puts out more work over here. So for this cycle of work, this work goes into the compressor to pressurize the air to come back through here. So this is the TS diagram. Right here between 0 and 2 is generally the compression from the air going into a jet engine. So it's before it actually gets in the compressor, it compresses a little bit. From 2 to 3 is inside the compressor. This is the combustion chamber. It's ideally there's no pressure change in there. And we come through here and lose some temperature in the turbine, and then through the nozzle we lose more temperature and come back down to the outside pressure. It goes back to 0. The other one is the PV diagram. It just shows again the pressure increases slightly from 0 to 2. That's just air going, hitting the engine itself. Then from 2 to 3 is inside the compressor. No pressure change in the combustion chamber. And then the turbine loses pressure loses pressure through the nozzle and starts over again. So for the procedure, I believe from what I understood, session 1 and 2 are the only ones happening in the actual lab. Everything else is outside the lab. Here we're going to start the machine up, operate it, get the data from it, and then shut it down. We're going to have data plots that we get all of our information from to do the calculations. Then we're going to use, like I said, first law principles to analyze data, figure out the workout, the heat in and all that needs to go in to understand what it's doing. Engine performance analysis is the turbine engine, how much it's putting out, and how much it's taking in. Because you have the energy going from the combustion into the turbine, that's back to the compressor, and some that's going out. And then this is the electrical generation, so how much of the net work is going to the alternator. So these are the equations that we're going to use. From here, these numbers are all wrong. So H2 to 1, H1 is here, 2 is here. That's our work from the compressor. Here's our fuel, the Q from the fuel. And then here is the work of the turbine. So you take that and add in the work of the compressor to get your net work. This is actually going to be negative because it's work out of the system. And then the efficiency is the net work over the cube of fuel. These are my predictions. We're going to have about 280 for H1, 637 for H2, 1300 for H3, and H4 is 831. So when you come down to it, the work compressor is about 348, cube of fuel 679, turbine negative 484. Like I said, it's work out, so it's negative. So our net work is 136, and our efficiency is about 20%. Sources of error, wrong values of thermodynamic tables, uncalibrated sensors, and since it's outside, variable weather that we can't really predict. Any questions?
Right. Well, a minute over. More than a minute over. I was a little confused, by the way. When you get work from a system, is it positive or negative?
Depends on your sign convention.
So what is your sign convention? What
It
is the
says work being put out by the system was negative and work coming into the system was positive.
Really? Is that what you guys did?
That's what I did. I don't know what everybody else does.
That's what you did. So what's your first law then? Write down the first law for me for the control match, which was sign convention. Interesting. Which textbook did you use for your undergraduate class?
From a what class?
Undergraduate thermal class.
No idea. I don't remember anything from thermal.
What do you remember this page?
I looked all of this up for this presentation.
No wonder. You know what you did? You looked up a website that's probably based in Europe. Written by a European, basically. In Europe, what you said is correct. If you get work from a system, it is negative. Work that goes into a system is positive. In the US, we do the opposite. If you get work from a system, it is positive. Work that goes into a system is negative. Right? And then the first law changes for us. Our first law is delta U is Q minus W. Right? And you wrote it down correctly, which is fine. So you remember that bit. And then, what happened to your numbers in your gas turbine cycle? What happened to 1 and 6 and 7? Right, there you go. What happens to 1? What is 0 to 1? What? Do you not like 1? Do they not like 6 and 7?
You got to talk to NASA about that.
They want to talk to NASA over there? Why would NASA not like 6 and 7? What do they do? Why would they do it? You should ask, but I mean, something is happening. Why did they just do 0, 1, 2, 3, 4, 5, 6, 7? Or whatever, 0, 1, 2, 3, 4, 5, 6.
I don't know, they don't like those two odd numbers.
And then you should switch this. See, if you stuck with that diagram, I would have changed the numbers and the equations you wrote down. Right? If you look at the graph that you have, what is the work of the compressor? Using the numbers on the graph, what's the numbers? H, 3, 2?
32, yeah.
And then what's our fuel? What's fuel? Oh, I want to heat up the fuel. Which number is that for you? What two numbers are those?
Q fuel will be 3.4, or 4 minus 3,
4 minus 3, correct? And then turbine is,
5 minus 4.
oh, it's your sign convention. Yeah, that'll work out. There, you know, you still keep your, next one, okay, fine, that's fine. Next speaker.